Ever looked out of a plane window and wondered why it's round? It's a question that might not cross your mind often, but it's a fascinating one. The design of airplane windows is a crucial aspect of aviation safety and engineering. Let's dive into the reasons behind this seemingly simple yet incredibly important design choice. You might think, hey, square windows work fine in houses. And you're absolutely right. In our homes, square windows are the norm. They provide a clear view, fit well with the architectural design, and are easy to manufacture. But the environment inside a house is vastly different from that inside an airplane. But up at 30,000 feet, things are different. The conditions are extreme. The air pressure outside the plane is much lower than inside the cabin, and the temperature can drop to incredibly low levels. These factors create a unique set of challenges that engineers must address to ensure the safety and comfort of passengers. Square windows might look cool, but they're a big no-no for planes. In the early days of aviation, some aircraft did have square windows. However, this design led to catastrophic failures. The sharp corners of square windows are stress concentrators, meaning they are points where stress is much higher than in other areas. This can lead to cracks and, ultimately, structural failure. Why? Because they can't handle the huge pressure difference between the inside and outside of the plane. When an airplane ascends to cruising altitude, the pressure inside the cabin is maintained at a level comfortable for passengers, while the outside pressure drops significantly. This difference in pressure exerts a tremendous force on the airplane's structure, especially on the windows. Think of it like blowing up a balloon. Too much air, and it pops. The same principle applies to airplane windows. If the windows can't distribute the stress evenly, they are at risk of failing. Round windows, with their smooth, continuous shape, are much better at handling these stresses. They distribute the pressure evenly around the edges, reducing the risk of cracks and failures. Same idea with a square window at high altitude. The sharp corners of a square window create points of weakness where cracks can start. Over time, these cracks can grow and lead to catastrophic failure. Round windows, on the other hand, have no corners, so the stress is distributed more evenly, making them much safer for use in airplanes. So, buckle up. We're about to dive into the fascinating world of airplane windows and why round ones are the true heroes of the sky. From the early days of aviation to modern jetliners, the evolution of window design has been driven by the need for safety and efficiency. Understanding the science behind this design choice not only gives us a greater appreciation for the engineering marvels that airplanes are, but also highlights the importance of seemingly small details in ensuring our safety at 30,000 feet. Back in the early days of aviation, planes were basically flying tin cans. These early aircraft were marvels of engineering for their time, but they were also incredibly rudimentary by today's standards. Made from wood, fabric, and metal, they were fragile and often unreliable. The pilots who flew them were true pioneers, pushing the boundaries of what was possible in the sky. They had to contend with all sorts of challenges, from unpredictable weather to mechanical failures. But perhaps one of the most overlooked issues was the design of the windows. And guess what? They had square windows. These windows were a common feature in the early days of aviation. At first glance, they seemed perfectly fine. After all, square windows were easier to manufacture and install. But as planes began to fly higher and faster, the limitations of this design became painfully apparent. The square shape created points of weakness where stress could concentrate, making the windows more susceptible to cracking under pressure. Pilots were daredevils back then, risking their lives to touch the sky. These brave men and women were often seen as heroes, and for good reason. They flew in open cockpits, exposed to the elements with little more than a leather helmet and goggles for protection. They navigated using basic instruments and their own instincts, relying on their skill and courage to get them through each flight. The thrill of flying was matched only by the ever-present danger. But those square windows? They were trouble. As planes flew higher and faster, the windows couldn't handle the pressure. The higher altitude meant greater differences in air pressure between the inside and outside of the aircraft. This put immense strain on the windows, especially at the corners where the stress was most concentrated. Engineers soon realized that the square design was a fatal flaw that needed to be addressed. They cracked. Sometimes they even shattered mid-flight. Imagine the terror of hearing a loud crack and seeing the window next to you start to splinter. For passengers and crew alike, this was a terrifying experience. The structural integrity of the aircraft was compromised, and in some cases, it led to catastrophic failures. It became clear that a new approach was needed to ensure the safety of everyone on board. Imagine being a passenger on one of those flights. Yikes! The fear and uncertainty must have been overwhelming. Passengers had to trust that the pilots and engineers knew what they were doing, even as they faced these terrifying challenges. The experience of flying was still new and exciting, but it was also fraught with danger. People were willing to take the risk for the chance to be part of this incredible new adventure. It was clear something had to change. The future of flight depended on it. Engineers went back to the drawing board, rethinking the design of airplane windows. They eventually settled on a more rounded shape, which distributed the stress more evenly and significantly reduced the risk of cracking. This innovation was a crucial step forward in making air travel safer and more reliable. The lessons learned from those early days of aviation continue to inform the design and engineering of modern aircraft, ensuring that we can all fly with greater confidence and peace of mind. Here's the science bit. When a plane climbs, the air pressure outside drops, but inside the cabin stays pressurized for us to breathe. This creates a big pressure difference. Now imagine that pressure pushing against a square window. The corners of the square become weak points. They're like the sharp edges of a piece of paper, easy to tear. The pressure builds and builds at those corners, putting stress on the window. Eventually, crack. The window fails. Circles are nature's strong shape. Think of bubbles, planets, even the human eye. They're all round for a reason. Strength. A round window distributes pressure evenly around its curved surface. There are no corners for the pressure to concentrate on, so the stress is spread out. This makes round windows much stronger and less likely to crack under pressure. They're the superheroes of airplane design. Section 5, From Square to Round, a design revolution in the sky. The switch from square to round windows wasn't just a fashion choice, it was a matter of life and death. In the 1950s, a plane called the de Havilland Comet had a series of disastrous crashes. The culprit, you guessed it, square windows. These crashes were a wake-up call for the aviation industry. Engineers realized the importance of round windows for passenger safety. Section 6. More than just a circle. The engineering behind modern plane windows. Today's airplane windows are engineering marvels. They're made of multiple layers of strong, transparent materials that can withstand incredible pressure and temperature changes. The outer layer, called the scratch pane, protects the window from bird strikes and debris. The middle layer is the structural pane, which provides the window's strength. And the inner layer, the cabin pane, is what you touch. Section 7. Fun fact time, cool trivia about plane windows you never knew. Airplane windows are more fascinating than you might think. Let's dive into some cool trivia that will make you appreciate them even more. Here are some fun facts about those round windows. Ever notice a tiny hole in the bottom of the window? This tiny hole is called a bleed hole, and it serves a very important purpose. It helps regulate the pressure between the inner and outer panes of the window. Without this small but crucial feature, the pressure difference could cause the window to crack or even shatter. So next time you see that little hole, remember it's there to keep you safe and comfortable during your flight. It's called a bleed hole, and it helps regulate pressure between the window layers. The window itself is made up of multiple layers, usually 3. The outer layer is the strongest and is designed to withstand the external pressure and environmental conditions. The middle layer is there to provide additional strength and insulation, while the inner layer is the one you can touch and see through. This multi-layered design ensures that the window is both strong and safe. Airplane windows are stronger than the fuselage. This might come as a surprise, but the windows are actually designed to be one of the strongest parts of the airplane. They have to be, given the extreme conditions they face, from high-altitude pressure differences to the potential impact of debris. Engineers put a lot of thought into making sure these windows can handle just about anything. In case of a sudden decompression, the windows are designed to stay intact. This is crucial for maintaining the structural integrity of the aircraft. If a window were to break during decompression, it could lead to catastrophic failure. The design ensures that even in the worst-case scenario, the windows will hold up and keep everyone inside safe. The windows are slightly tinted to reduce glare and help regulate cabin temperature. This tinting is not just for your comfort, although it does make it easier to look out the window without being blinded by the sun. It also helps keep the cabin cooler, which is important for both passenger comfort and the efficiency of the aircraft's air conditioning system. The tinting can also protect you from harmful UV rays, adding another layer of safety. That fresh air you smell on a plane, it's not just recycled air from inside the cabin. Some of it is actually drawn in from outside the aircraft. This fresh air is brought in through the engines, where it is compressed and then mixed with the cabin air. This process helps to regulate the pressure inside the cabin and ensures that you have a constant supply of fresh air to breathe. Some of it is actually drawn in through the engine and used to regulate pressure in the cabin. The engines play a crucial role in maintaining the cabin environment. They don't just provide the thrust needed to keep the plane in the air, they also help manage the air quality and pressure inside the cabin. This is why you might notice a slight change in air pressure or temperature when the engines change their power settings. It's all part of the complex system that keeps you comfortable and safe during your flight. Section 8. The future is round. Why this design is here to stay. Round windows have been the industry standard for decades, and for good reason. They're safe, reliable, and they just plain work. Sure, designers are always experimenting with new materials and shapes to improve efficiency and comfort. But when it comes to the fundamental shape of the window, round is here to stay. Section 9. So, next time you fly, appreciate the round window beside you. The next time you're soaring through the air, take a moment to appreciate that round window. It's not just a portal to the world outside, it's a testament to the ingenuity of engineers and a symbol of safety in the sky. And, hey, if you ever see a plane with square windows, run the other way. Just kidding, mostly.